Okay, we're looking at the textbook for, the practice paper from the first year textbook, and we are on question 7. Okay, so we've got a straight line graph where they've plotted log to the base 10 of p against t, and they have told us that they think, so this is about a colony of endangered Caledonian owlet nightjars, okay, and they've told us they think that can be modelled by this exponential equation. Okay, right, so the first one is very straightforward. Write down an equation of line L. So this is line L, okay, and it's clearly just a straight line. So we're thinking y equals mx plus c. Let's get that up. Okay, except, this is where you need to be careful, it's not y, it's log to the base 10 of p. And if your equation is y, you actually won't be able to score any marks for this. Okay, so our axes aren't x and y, they're log to the base 10 of p and t. Okay, so that equals the gradient. So they haven't told me the gradient, but they have clearly given me 2 points on that line. So if I just go back to the gradient is the change in y, so that's going to be 2.2 minus 2 over the change in x, so that's going to be 20 minus 0. That is going to be 0.2 over 20, so the gradient is 1 over 100 or 0.01. Okay, so there's my gradient, and again, it's not x, it's t, and I can clearly see the y-intercept is at 2. Okay, so quite straightforward for 3 marks, but like I said, if you just put y there, you actually won't be able to score any marks, or you might be able to just get 1 mark for working out the gradient. Okay, so work out the value of a and interpret this value in the context of the model. So we'll worry about interpreting it at the end, and this is worth 3 marks, so we're expecting to do a little bit of work here. So a, they've referred to in the exponential model. So, okay, so the exponential model was p equals ab to the t. So I want to take logs here because they've linearized this. Now, if you already know the results, then that's absolutely fine. You might not need to take logs. And I'm just going to go through the whole method. So I'm taking log to the base 10 of each side. Then I can separate that right-hand side out, and then I can bring that t down as a coefficient. So you might already have known that that was going to be the result. You've practiced quite a few of these, but otherwise you can just go the linearizing. Right, if I then compare that to my answer to part A, and I'm actually just going to switch the order around, okay, because what I'm looking at is, so obviously they are both the same. This is my term in t, and this is my constant. So that's what I'm interested in for this part of the question. So they want me to work out the value of a. So looking at this, I can say, well, log to the base 10 of a is 2. So a is 10 to the power of 2, which is 100. Okay, so that's the value of a. And then they want me to interpret this in the context of the model. So if I go back to the model, so a is going to be the value of p, so the population, when t is 0. Yeah, so if I substituted t as 0 into that exponential model, b to the power of 0 would just be 1. So a, let's write that down. So, oh, sorry, I just realised you probably couldn't see my final bit of working there. So there's my value of a. Okay, and a is the starting population or the initial population, or the population when t is 0, anything that basically means that. Okay. Work out the value of b and give your answer correct to 3 decimal places. So there's a bit of a clue. I'd be feeling quite confident about my answer to b at this point, or the value of a, because they didn't mention rounding for that, and we obviously didn't need to because it came out as an integer. Okay, so we've already sort of pretty much got ourselves set up to find b. So for b, I'm looking at this bit here. So I'm comparing the coefficients. So on my straight line equation, the coefficient of t was 1 over 200. And on my linearized equation, the coefficient of t is log to the base 10 of b. So that means that b is 10 to the power of 1 over 100. And they've told me to round that, so I'm expecting a decimal answer. And they told me to give it to 3 decimal places. So I'm getting that as 1.023. Okay, and they didn't ask me to interpret that, which is good. And find the population predicted by the model when t is 30. Okay, so I've actually, I could use my straight line equation, but now I've got the values of a and b, I can actually just put those into the exponential equation. And t, they wanted me to find the population when t is 30. So t is 30. Okay, that is going to become, now it's going to make a difference actually. So I've still got the full solution to b in my calculator. And it probably is going to make a difference whether I use that or whether I use the rounded version. I'm going to use the rounded version because they did tell me to round to 3 decimal places. And that gives me 197.8, so I'm going to say 198. It doesn't mention rounding, so I should be fine to go to, I should be fine to go to 3 significant figures or the nearest whole number, sort of in terms of what makes sense in the context of the question. But I think if I go onto their solutions, yes, you'll see there. So it will accept anything from 195 to 200 because it will sort of, your answer might vary depending on how you've rounded your value of b.